In previous section, I told you that show IP Eigrp topology command will tell me about the topology table, and the routes that are feasible are going to be shown to me. And what does feasible means? Feasible means that this route has a feasibility condition. That means its reported distance is less than the feasible distance. Here, of course, I have one route, and you can see that the amount of feasible distance is the exact amount of the metric that this first route has. But if we had more than one route, we could check the feasible distance and see which routes are feasible. That means have feasibility condition and their reported distance are less than our feasible distance. Let's check the show IP Eigrp topology, and now I'm going to add all links parameters to this command. You can see that here now we see more routes to reach one destination. Let's check one of these routes, for example this route. Okay, now to reach to 10,000 I have one successor. That means one of the routes are feasible. I could have, of course, more successors if I had more routes in feasibility condition, but it tells me that only one route is feasible. And you can see that it tells me the feasibility distance is 2,100,000. And if I check here the routes that are here, okay, I have 3 paths to reach to the destination. One of the paths goes through serial 00, and you can see that this is selected to reach to the destination. The other path tells me that I have 2,600,000 to reach to the destination, and this is feasible because my reported distance is 2,100,000, and this is exact amount of feasible distance. So this route is feasible, and I can install it in topology table. And the other amount tells me that I have a path that goes through fast Ethernet 01, and it has a reported distance that is exactly the same as the feasible distance. So this route is going to be added to my topology table as well. So of course this is a summary address. I'm not going to use this. No, this is not a summary address. This is the address of the frame relay cloud. Let's check another address here. I can say that 10.0.25.0 has only one successor, and its distance is 30,000. So I have 2 paths here, and these 2 paths have 28,000 as the reported distance first, and 2 million as the reported distance for the second path. The first path has less reported distance, less metric for the reported distance than the feasible distance that I have here. So this is a feasible route. So this is going to be added to my topology table, and this is going to be installed in my routing table, of course. The second route that goes through the serial interface has a reported distance that is much higher than the feasible distance. So this route is not feasible, and it is not going to be installed nor in my neither in my topology table nor in routing table. So this is the feasibility condition that I have here. So to change this feasibility, I can change various variables. For example, I can change the minimum bandwidth, I can change the delay, and to see the detailed information about one route, I will go and check the show IP Eigrp topology, and I'm going to hit Ctrl W several times to delete this word. I'm going to paste 10.0.25.0, and that's a 24-bit mask route. Now you can see that I have 2 paths here. The first path has 30,000 as its metric, and you can see that the same amount is here as feasible distance. So this is the feasible route, and the second route has much higher reported distance, and this is not going to be installed in my topology table and not going to be used as a valid route. So this route is not important, but you can see that for the first route I have 100,000 kilobit per second as my minimum bandwidth that is the minimum bandwidth in between me and the destination. If I have several routers in between me and the destination, and these routers have different bandwidths on their interfaces, the minimum one will be used for the calculation of EIGRP, and you can see that this minimum one is 100,000 here. The second route tells me that the minimum bandwidth is 1544 kilobit per second. So if I have, for example, several hops between me and the destination, the minimum interface speed is this much. And this tells me, of course, I have 2 hop counts. That means I have 2 hops to reach the destination. The second piece of information that is important is the amount of delay. You can see that here I have 200 microseconds, and here I have 40,000 microseconds. The amount of bandwidth and the sum of the delay of all interfaces between me and the destination are used in calculation of the metric for EIGRP. So the second route has much more much more metric that you can see this here. Now if you want to change this amount of bandwidth, now you have 2 options. For the first option is to decrease the delay in interfaces, and this involves changing the delay of several interfaces, and this is not desired. The second option is to change the bandwidth of the interface that is a bottleneck between me and the destination, and this is not going to be a desired option, because bandwidth is used by several processes, and every process has its own calculation for using the bandwidth, so this is not good to change the bandwidth. One other way is to change the variance variable, and I'm going to talk about variance in the next section, I guess. So the next command that I'm going to use here is the IP bandwidth %, and this is going to be configured because I want to limit the amount of bandwidth that EIGRP uses for its messages. EIGRP has several messages. One of them is hello, the other are update messages, the other one is query messages. So these messages use bandwidth, and I'm going to limit the amount of bandwidth that EIGRP uses so that it does not congest the link between me and the destination. So to do this, I can go to configuration mode, I can go to interface configuration mode, and I can use IP bandwidth %. And for EIGRP 100, I'm going to use about only 30% of this interface's bandwidth for EIGRP messages. So I hit enter, and now I'm sure that 70% of the bandwidth is always available for other processes, and this 30% is the peak that is going to be used for EIGRP. So this is a piece of command that is very, very useful in limiting the bandwidth. Of course, you can use QoS for this, and I'm going to talk about QoS in next sections. But this is the manual configuration on one or several interfaces that you go and configure.